Hello, welcome back to part two of week two, module two. So we're sort of continuing on talking about the geographic templates, or some of those foundational things that influence some large scale geographic patterns that we see. And I'm going to talk a little bit about soil types and soil formation here as we're sort of working our way through these different things. Soil is you have temperature and precipitation are probably two of the largest geographic influencers, biogeographic influencers, that is. But soil is also a really important characteristic of the physical landscape that tends to get overlooked. And I'm probably, I am part of this problem, I guess, myself. Like, I'm not a soils person, but I'm a forest ecologist, and soil is actually very important in soil ecology or forest ecology. So it's worth mentioning, even though it doesn't get as much attention as it probably should. So I just want to briefly mention some things here. So temperature and precipitation are actually drivers of soil formation. So depending on the overall temperature, if you have a cool sort of temperature with sets abundant sort of reasonable levels of precipitation, then you can get something called podzolization, where you're getting these organic debris and humus-rich sort of infiltration or alluviation zones. There's a lot of stuff going on here. I'm not expecting you to really memorize this. We're not going to get into how much hydrogen ions are moving through the soil. We're not going to really get into that level of it at all. But just something to take away is that this overall pattern, that temperature and precipitation can influence the soil formation. If you have warm conditions and heavy precipitation, then that's getting more towards laterization, where you have little or no organic debris, and can influence the where the water table is and exports to the stream. Calcification is more of a process when you have under cool or hot conditions, but very low levels of precipitation. So sort of desert-like conditions. And glazation is sort of cool conditions, or glazation, I forget how you actually say that, but cold, but sort of wet conditions. And so, basically, yeah, just the temperature and precipitation are going to influence the weathering rate and what, the turnover of organic material and sorts of and things like that. On a broader scale, we can sort of categorize what sort of environments we get or we see depending on whether things are cold or hot. Overall, like average temperatures, and whether they're arid and dry or more wet and humid. If you have a cold and really dry environment, then you get these sort of alpine polar like deserts. Whereas if it's hot and dry, then you get red deserts, or really just like the Sahara type conditions. But if you have humid and hot conditions, then you get rainforest latisols. So it's the soil condition or soil formation is going to play a role in what sort of overall environment you get. You have these tundras type or Arctic brown sort of tundra environments where it's cold, but maybe moderate levels of precip, or even high levels of precipitation. So it just kind of depends, and that has an influence. Even here, sort of around where we are, you get sort of maybe a transition into from moderate temperatures to moderate precipitation, somewhere in here, maybe somewhere in here, high levels, depending on where in the eastern United States you are. So yeah, something to be aware of there. And we see this at a global scale too, where major biomes correspond to major types of soil. And some of this is really getting down to just the temperature and precipitation drivers. You can see it sort of follows like some of the other maps that we looked at for temperature and precipitation. Is going to have an influence. Like, something I didn't really talk about is you have these mountain ranges in here, which has dramatic impacts for precipitation across the western United States. And if you're from the West, or if you're just familiar, the western United States is a lot drier than the eastern United States. And part of that is because of these vast mountain ranges. And you get this moist air that gets pushed, or this wet air that gets pushed from the ocean over those mountain ranges, and then you get that adiabatic cooling and the rain shadow that causes these deserts in here, and that corresponds to some of these soil types. as well. And you tend to see some of this with increasing elevation, where you can get, sort of a clay, high organic material in lower elevations, and then as you move up, it's just sort of getting less organic material and maybe even less weathering has occurred. So you transition sort of from clay to sand to gravel to even not even really soil, but just the bare rock and boulders. Okay, so I sort of want to transition here. So that was soils, and we'll talk more about soils, and it's not going to be a huge component, but it's at least worth mentioning and always keeping in your mind that plays a role too. Something else that this class tends to be very terrestrial focused, and I think that's probably the case with a lot of ecological type studies, but there's obviously, like, most of the world is not terrestrial, so it's worth also mentioning the aquatic environments too. And so there's some different sort of patterns here that we see. I sort of already mentioned some of these in the gradients, where you get, if you increase in depth, you get a decrease in temperature. And these sort of figures are always hard, I think, to introduce because they're kind of backwards in how we think. So the y-axis is sort of reversed. So you're increasing in depth by moving down the y-axis. So down here is deeper, and then this is your temperature, which normally you would think would be on the y-axis, but for visualization here. So it's just kind of funky to wrap your head around these sorts of aquatic temperature plots. But what you see here is what you get is this thing called a thermocline. And a thermocline is, so if we're starting at the surface and we are moving down in the water column, we're gonna, as we increase in depth, we're gonna get a decrease in temperature. So you can see, this is, let's just focus on this line right here. It's moving slightly to the left. You can kind of see that. So, you're getting a decrease in temperature as you move this direction. The thermocline is this area where you get this really steep decrease in temperature over very little change in water depth. So basically, this portion where it goes horizontal, hardly changing depth at all. I mean, it is a little bit, but not much. But it's obviously the temperature changes is really dramatic here, going from almost 24 degrees to almost 12 degrees. So that's the thermocline, where you get this rapid decrease in temperature, and it happens a lot in basically almost any aquatic environment you're going to be looking at. You're going to get this thermocline. The extent to which it exists is based on a couple different things. One of those is the time of year. So if it's winter, you get this ice formation, and it can sort of invert things, and you get less of a change in temperature because of differences in solar radiation and how much water is moving, sort of recirculating around here. But what's driving most of this is the fact that not much solar radiation is actually absorbed down very far. Most of the solar radiation that hits water is absorbed very or in the surface water, so very high up in the water column. In fact, like 99% of all incident solar radiation is absorbed in the upper 50 to 100 meters of water. And so surface waters tend to be much warmer than the deeper water. So that's sort of the crux of what we're getting at here. But there's sort of two main, I guess, implications of this. One is that most of the photosynthesis occurs only in surface waters, because that's where most of the light is. And if you know anything about photosynthesis, is that one of the main ingredients is solar radiation. You need light for that to happen. And so if there's no light reaching deeper areas, then you're not going to get photosynthesis that's actually occurring. And some of that actually has to do with the wavelengths that get absorbed. This isn't a limnology class, so I'm not going to get too much in the fact that, I think like blue and red wavelengths can reach a little bit deeper, but other wavelengths don't, or one or the other. I actually can't remember. But anyway, most of the radiation is absorbed in that upper layers. So there's just not enough light for photosynthesis to occur in deeper waters. And then also, like I said, only surface waters tend to be heated. So that obviously plays a role in what sort of organisms can survive in those types of conditions as well. So that's soil. I wanted to sort of briefly talk about soil formation in aquatic environments because those two things tend to get sort of left behind, but those are worth mentioning when we're talking about sort of these broad overarching things. So keep working your way through the module. There's one more part, but for part 2, there's still there's a reading. So read about the permafrost, and then there's a little discussion exercise where I'll ask you to go look at some soil data online and tell me what you found about some specific locations and what sort of soil types they have. So keep working your way through it, and I will see you in the next video.